And welcome back to GCSA TV Live, kind of. My name is Chris Gray, and I'll be the host for this segment where I am joined by Dr. Mike Fidanza, Professor of Plant and Soil Sciences at Penn State University. Mike, thanks for taking some time to talk with me today.
Great, Chris. Thank you for having me.
Absolutely. Actually, you were a guest last year that we had, and we talked about a few different topics last year, and I kind of wanted to talk with you again, and really more about some of the things we didn't get to touch on last time. What we really want to talk about is dealing with what we think some of the additional benefits of dealing with fertilizer actually is, because I know that for a lot of us, we think that fertilizer really is more kind of a cause-effect relationship. We go out, we put fertilizer down, we get growth, hence the cause and effect. But in reality, there's a whole lot more that's really going on out there. And so I figured bringing someone like you on that really has a much better understanding of this stuff, I thought we could kind of get to the bottom of it. So if we're talking about like proper turf nutrition, if we're talking about there's a whole lot of other benefits that go along than just kind of you fertilize and the grass grows. Kind of walk me through a little bit about what some of those other benefits really are from a very high level 30,000 foot view.
Okay, well, thank you, Chris. First of all, I want to apologize for my office being not that well cleaned up during the pandemic. I haven't had a chance to clean it, but don't I look professorial with all these books in the background there?
Very academic.
Yeah, thank you. Well, let me take a step back if I can. Drawing from my introductory soil science course that I teach, when we talk about soil fertility, plant nutrition, I like to think of soil in terms of three sort of parts. There's soil physical properties, soil chemical properties, and soil biological properties. And you think about soil physical properties, well, let's look at the root zones. We have sand-based root zones, mineral soil root zones, okay? And our sands, they're not going to hold nutrients like our mineral soils, like our clays and our loams, okay? Then you have the biological component. Very important, that microorganism, the soil biology is important for nutrient cycling and to convert ammonium to nitrate. Those kinds of processes are very important. The soil biology is very important. The soil chemical properties, don't forget about those either. The pH specifically, we like to say that a soil pH should be between 6 and 7, the sweet spot for soil biology to maintain its maximum performance, maximum function. And also that pH of 6 to 7, many of our nutrients are available for plant root uptake in that range. That could be a little more on the acidic side, a little more on the alkaline side. So take the big view of things is looking at soil physical properties, soil chemical properties, soil biological properties to help frame an overall sort of soil fertility program, plant nutrition program. And then one more item, we think about fertilizers and as far as fertilizing turf, and we have to think about the plant and we think about the soil as well. We put both of those together, as opposed to, and not in a disrespectful way, agricultural crops, the focus is yields, okay? Production agriculture, the focus is yields, yield quantity, yield quality. In turf, we talk in terms of yield, but in terms of mowing and turf performance and surface quality characteristics, that kind of thing. So again, yeah, Chris, that's sort of my big picture view of soil fertility.
Well, I think you're right. So if we talk about granular fertilizer, you hit on a point that's very important, and that's the fact that the soil is the medium that we're actually applying the fertilizer to, that then is used to take the nutrients and bring them up into the turf grass plant itself. I mean, and so sometimes that gets lost. So is it fair to say that successful turf managers really need to take a holistic approach in understanding what's going on in both the soil and the plant simultaneously when they're trying to come up with a fertility program? How important is that to know both causes?
I agree with that. I think we need to focus on what's in the root zone. Okay, let's focus on the upper 3 or 4 inches of that root zone, and then look at the turf in terms of, I think it's important to think of expectations. Greens, fairways, tees, roughs. What are the expectations? Visual quality, performance standards. Okay, so you think about the expectations and think about how we want to feed the turf, so to speak. How do we want to manage the turf cultural practices wise to get those expectations to where we want them? And then think about the soil. You're right. Think about what's in the root zone. And this is where a soil test report comes into play here. We want to know what nutrients are in that soil root zone. What nutrients are there for plant uptake? What nutrients are available? We're looking at plant available nutrients. And this is where soil testing is important. And you talk to golf course folks, superintendents, turf managers, they're constantly measuring their soil, sending soil samples off to labs for analysis. This is routinely done, and I think that'll help establish sort of like baseline of nutrition in our root zone, so to speak. And from a turf manager's point of view, what nutrients are there, what nutrients have to be added to take our turf to the level that we want. There's some different ways of interpreting the soil test report. And, I love the golf course superintendents because every one of them has sort of their own unique way of fertilizing and their own view of plant nutrition and soil nutrition. Feed the soil to feed the turf. It all comes together, like, as you mentioned, this holistic approach. And every time I talk to a superintendent and visit a golf course, I always learn something about nutrition and how they perceive nutrition and how they perceive soil health and how it all comes together. And like I said, everybody has sort of their own kind of unique recipe, and it all works in one way, shape, and form.
So, talking about the soil test as well as tissue tests, I mean, those are very important tools. I mean, it gives us an insight to what's going on in there. How often do you recommend actually having those done? Because we know that elements like nitrogen goes through very quickly and changes very rapidly from one to the other. What's kind of your recommendation for how often you should be doing a soil test or doing a tissue test to kind of give you the proper insights that you need when you're looking to develop a program?
Okay. I guess what I've seen, a good rule of thumb is once every 3 years. And some superintendents I talked to, or many, they would soil test, say, 6 greens in the first year, the next 6 greens the second year, the next 6 greens the third year. And they would do that with fairways and maybe tee areas and occasionally roughs. But that's a good rule of thumb once every 3 years to establish some baselines and to see what are the nutrient, what's the soil test telling you. Again, you mentioned nitrogen. That's going to be based on again, the expectations and overall turf management programs. But what's in the soil test is phosphorus and potassium and other components, pH, of course, that you can see. And it's good to have those soil tests every 3 years. And then as management, the management techniques are being employed, you can see if there's changes to those levels over time. And it's always we always say that if you send off soil samples to a test lab, stick with the same test lab year after year after year, so you can make standard comparisons. Every test lab kind of sort of produces the same results, but they might differ in terms of some of their reagents used and some of their methods. So it's best to stick with one lab and time again. Then you can compare long range. But yeah, that would be my recommendation for soil testing. Typically 1 time in 3 years.
For the soil test, I know that there's other information that's provided on there that's beyond just what the levels of your parts per million of potassium or phosphorus is, but a lot that's dealing with kind of what the cation exchange rate is. You get a better idea for what the proper ratios are between the nutrients. How much attention should they be paying to what that information tells you, and how much should it be used to kind of tweak the program for what they're trying to develop?
Well, Chris, that's a great question. It gets into some nice debate. You could sit down with some superintendents and various industry reps and over a few beers and discuss this for hours. Some folks, it reminds me of my youth as a young lad going to the racetrack, Delaware Park there, and betting the horses with my father and his old Italian buddies. And we would look at this, and they would look at that at the track program, and each horse had all this data with each horse, what their latest race was, what their times were, and they would study that program like we study soil test reports. And they would hand me the money, and I would go make the bets for them. This is my misspent youth. we could talk about that in another lecture time. But what I'm getting at is that soil test report, you can pour into this and read into this and overanalyze, underanalyze. It depends what you're comfortable with. Some folks rely on looking at the cation exchange capacity and the base saturation cation ratio. That base saturation, percent calcium, percent magnesium, percent potassium, percent sodium, that are sort of parked on those soil exchange sites. Think of it like big parking lots. And some folks will say, well, if these nutrients exist in certain percentages, again, calcium is a 2+ charge, magnesium is a 2+ charge, potassium is a 1+, sodium is a 1+. These nutrients are parked in certain spots on the soil colloid. That means they can potentially be available for plant root uptake. And these nutrients have to be there in certain percentages. There have to be certain ratios. And some folks, they have their own sort of formula on how this should be. Other folks may discount that and say, well, that gives you an indication of the potential fertility of that soil. But what we really want to look at is nutrients in soil solution, because roots are taking up, nutrients when they're floating in that soil water, those films of soil water around the soil particles. So there's two debates as to how we go about this. But I think both methods get you to somehow developing your own recommendations. There's also the minimum level of sustainable nutrients, sort of a newer way to interpret soil test reports. But what I was getting at is, it's interesting because some folks, it's just what they're comfortable with. They may be more familiar with looking at ratios and nutrient levels, and they say, okay, I need to add calcium, or I need to add magnesium, or I need to add certain fertilizers to get the ratio where I want it. And that's the results I see in the field. To me, that shows up better. I get better turf quality, better performance.
Right.
And other folks may see things a little differently. Again, I think it just depends on what you're comfortable with. I know, just taking a step back, soil test labs at universities, they tend to base their fertilizer recommendations on what nutrients are available in the soil solution, based, to sort of focus on the yields. That's university soil test labs. I know commercial soil test labs tend to rely on the base saturation cation ratio to make recommendations. I can't argue that there's a right or wrong on either side, because folks like both methods. So I know that opens up debate, and folks can talk about one versus the other. But and you mentioned one last thing about soil tissue or turf tissue testing. I just reviewed some data on this, looking at anthracnose disease. This came out of University of Connecticut and at Rutgers. And just real quick, it showed that if the leaf tissue content was 3% nitrogen or less, that turf, the annual bluegrass specifically, was more susceptible to anthracnose. So with tissue testing comes into play, it might be beneficial to do that. It's a little more expensive when you're trying to dial in some disease management programs, that kind of thing. So for anthracnose, for example, if you need to get the nitrogen tissue level up above 3%, that significantly reduces anthracnose severity. So that's where tissue testing might really help.
Okay, so let's switch gears real quick, and I want to talk about some of the supplemental products or groups of products that are out there that are really having an impact when it comes down to fertility. I mean, lots of biostimulants. We got humic acid out there, seed plant, there's beneficial bacteria. I mean, what's your take on these supplements and how they interact to ultimately provide the final condition that superintendents are trying to achieve with their turf or the golf courses?
Yeah, well, I tell folks with biostimulants, they're not the silver bullet, as we say here in the States. I think you need to first establish dial in your own recipe, your own base soil fertility fertilizer program, and then you could add the biostimulants on top of that. There's different ways of looking at biostimulants. The European Union, they're trying to pass legislation, and it might be passed already, to classify biostimulants as to how they function versus what they are. Right now, we talk about their seed plant extracts and microbials and amino acids and phosphates and soil surfactants, different types of biostimulants. But the European Union want to classify them as how they function. In other words, if you buy a product with mycorrhizae in it, and mycorrhizae are known to improve root uptake of nutrients. Well, in order to get that biostimulant labeled as a root enhancing product, you have to have data to show that. And so that's the way the European Union is going. Maybe that'll trickle into the States here. So we have to think about biostimulants as really how are they functioning. So what do you want to achieve with a biostimulant? Do you want to turn on plant defense mechanisms? Do you want to aid that plant in abiotic stress, drought stress, or heat stress? And when you make these applications, unfortunately, a lot of times, in my experience, you don't really see visually anything happening. And you think, well, I just applied this product. Maybe it's a snake oil, as we say. It doesn't work. Well, maybe it is working. It's turning on defense pathways. It's turning on mechanisms in the plant. But we just can't see it until the plant is under heat stress or drought stress. Then we see some slight improved health, that kind of thing. Again, products like you mentioned, the humic acids and the humate products, they're known to increase the cation exchange capacity, right, in the soil. And you have to think, where do you want to use these? It goes back to soil physical properties kind of viewpoint. Our sands, our soils with low CECs, this is where these are good places to use these humate type products. So with biostimulants, I think you have to think about not just what they do, seed plant extracts, et cetera, but what do you want to achieve with them? Okay, with seed plant extract, they're high in cytokinins, and cytokinins help with chlorophyll to reduce chlorophyll degradation, that kind of thing. So helps with abiotic stress. So that's how I have to kind of think about it. Well, I want to use these products to achieve this goal: abiotic stresses, heat stress, drought stress, whatever. And I think that's how you have to approach it. And you have to, like, one last thing I want to say, you have to be really observant when you make these applications of biostimulant products. You have to really observe, constantly monitor to see if what you're doing is actually benefiting your overall program. You have to really scrutinize and be critical and ask the manufacturers of these products for some data and guidance on how to use them, that kind of thing. But always monitor, observe, take soil cores, look at roots. I know it's a lot of extra work, but that's the best way I've found it to determine if these biostimulants work for you. And again, I mentioned soil surfactants. They're kind of sort of placed in that biostimulant category now as well.
Sure.
I hope that makes sense, Chris. I know it's a lot to cram.
You know, it's great because I mean we could talk about this for hours on end. Unfortunately, we're kind of running out of time, and I want to say thank you for your time. I appreciate you taking time out of your day, having this discussion, and like I say, we'll definitely catch back up on this and have another discussion later on. So I appreciate it.
We can meet in person, but the next year at the GIS show, we can, I'm sure.
Absolutely. So until then, I appreciate everyone for tuning in. My name is Chris Gray with LebanonTurf, and stay tuned for the next segment of GSSC TV Live. Thanks.
Thank you.